What really has changed in the last 20 years is that we can change your biological age to some degree. Your cholesterol level is 7 times less important than your age. So imagine now that we're targeting aging, what it's going to do in terms of impact on your risk for heart disease.
You say that the phenomena that drive aging is primary. The diseases are secondary.
Aging is the biggest risk factor for a whole series of conditions that we call heart attack, stroke, atherosclerosis, many forms of cancer, type 2 diabetes, Alzheimer's, Parkinson's, all of these diseases. And so it really changes the paradigm of the way we've been taught medicine, which is to respond to all of these emergencies that occur, what I call whack-a-mole medicine.
If we targeted the underlying mechanisms of aging, we could extend life by 30 or 40 years. So what do you do for helping your immune system age well?
That's really the way medicine is going to change.
Dr. Eric Verdin is president and CEO of the Buck Institute for Research on Aging and a globally recognized leader in aging and science, a physician scientist with over 300 publications. He studies the intersection of metabolism, immunity, and longevity, helping shape the future of how we understand and treat aging. If you've been dealing with anxiety, low energy, or trouble focusing and still feel like you're missing something, you're not alone. And that's why I created the Brain Shaping Academy, a new program that looks in places most people never think to check, like nutrient deficiencies, the health of your gut, metabolism, your immune system, and lots more. So join the waitlist and get special pricing at drhyman.com/brain shaping. Eric, welcome back to the podcast. So good to have you again. I love talking to you. You're my favorite longevity guy because you're like the legit guy.
Thank you.
You do the studies. You've published hundreds and hundreds of papers. You do the real science. You really understand this field more than I think most people out there. And you're kind of willing to explore the margins and edges, which is great, but you're also kind of holding us to the truth, which I really appreciate.
I'm delighted to be here. And like you, I'm a physician. So I think, I think it takes for us to have gone through the root of what it means to deal with real lives to understand the implications of any statement that you make. And so, a number of people have taken to calling me the grumpy man of longevity medicine.
I don't see it that way.
And I take this as a badge of honor because I would rather be sort of a little more conservative than a little more adventurous.
Yeah, no, I agree. If I really want to know about something, I ask you. So with that said, one of the things I really love about your framing of longevity, because you're at the Buck Institute on Aging, is the framing around disease and aging. You say that the phenomena that drive aging is primary. The diseases are secondary. And that if we can attack the primary features of aging, which are not necessarily all inevitable, that we can change the trajectory of disease in a far greater way.
I love that you asked that question because it's a concept that came out of the Buck Institute. Mm-hmm. It's a scientific term. It's something we call the geroscience hypothesis, and it was published about 12 years ago by my colleagues. Gordon Lithgow was the leader of this, and it hasn't been paid attention enough. So I will restate what it is. Aging is the biggest risk factor for a whole series of conditions that we call heart attack, stroke, atherosclerosis, many forms of cancer, type 2 diabetes, Alzheimer's, Parkinson's, all of these diseases, osteoporosis, macular degeneration, sarcopenia, the list goes, your response to COVID-19, your response to
vaccines,
your risk of pneumonia, all of this is driven by aging. Now, when I went to medical school, which was already a long time ago, we were told, for example, for heart attacks.
I think we're doing pretty good for a couple of old guys.
And this work actually is helping. So there's a sense of urgency there. When you think about this and how medical school for heart attacks, the risk factors, most people can actually recite the risk factors: smoking, physical inactivity, obesity, and so on. Those were in a box in my textbook of medicine as a modifiable risk factor. There was another box, which was the unmodifiable risk factor, and that was your age and your gender. Now, we're changing both. But your age, what really has changed in the last 20 years is that we can change your age to some degree.
Your biological age.
Biological age. Not your chronological age, how many years you've lived. But
I'm waiting for that.
Yes. But so that...
Time machine.
That changes that whole equation because what people fail to recognize is, imagine your cholesterol level $20 billion industry with statins, a lot of success actually at mitigating, decreasing the risk for heart disease. Your cholesterol level is 7 times less important than your age. So imagine now that we're targeting aging, what it's going to do in terms of impact on your risk for heart disease. Now, the beauty of the system is that you're not only affecting heart disease, you're affecting everything. And so it really changes the paradigm of the way we've been taught medicine, which is to respond to all of these emergencies that occur, what I call whack-a-mole medicine, where you have a heart attack, we survive, we cure cancer, and so on, versus targeting the root core. So think about a tree with all of these branches being diseases. Now we're going for the core, the biggest risk factor, and that's aging. Now we are at early stage in trying to understand how this works. How do we actually interfere with the aging process? I think we can slow it down. There's some early evidence that we might be able to revert. And I think this is really what animates all of our work, is really the idea that we're going to be getting to the root core of all of these diseases.
Well, that's it. That's how I think is root cause. Like, how do we deal with root causes? That's what functional medicine is root cause thinking. And it's just a different way of thinking about things. And I heard it said that if we cured cancer and heart disease and we just got rid of them completely from the face of the planet, we'd extend life by 5 to 7 years. And if we targeted the underlying mechanisms of aging, we call the hallmarks of aging, we could extend life by 30 or 40 years. It's orders of magnitude more.
Totally agree.
Is that right?
Yeah, there seems to be, right now, based on what we know, there seems to be a hard stop at 115, 120. Very few people have gone, one person has gone above Madame Calment.
And she smoked and she drank and she ate chocolate, but she didn't get married.
Yes, and some have questions, the veracity of whether she was Madame Calment or her daughter who was collecting Social Security benefits. So there's been a lot of controversy, but, a handful of people have lived about 115. There's a hard stop at around 115. So imagine that everyone getting there. That's already. I imagine everybody getting to 95. That would already be amazing. So one of the reasons why sometimes, as we talked about, I'm called grumpy or unimaginative or not ambitious enough, is people feel that I should be projecting bigger numbers in terms of what we're going to be able to do in the future, and we might. But the bottom line is, no one can walk around and tell you, I'm going to live to 140, 150. We don't have any evidence for this, so why even say this?
I mean, the don't die thing is not real?
No.
You're not betting on that horse?
We're not even talking about immortality, because that's a whole other ballgame.
Yeah.
People talking about immortality say, I've said on the record, if you're looking for this, join a church. Don't come to the longevity field.
Yeah, exactly.
We are focused on two things. One is, what can we do really to push the envelope very far, but also what can you do today?
Yeah.
Because that's really the most important thing, to modify the way we...
This is so important because right now, there's a lot of cool things happening, like Yamanaka factors and some big money behind researching ways of gene modification or inserting transcription factors that regulate aging and can reverse biological age. Those are kind of sci-fi, and there's some real money and real research going on, and that might do something. But right now, what you're saying, what I hear you saying, is we can really look to getting to at least 100, most people, if we do all the things that we need to do, given what we know now. We focus on the fundamental mechanisms of aging, what people call the hallmarks of aging, and we're going to kind of dive into one of them in particular today, inflammation, or what we call inflammaging. Is that all these are related, they're all interconnected, they're not really all separate phenomena, they all kind of cross-talk, and they influence each other. And there are some meta frameworks that actually allow us to kind of push the field of those hallmarks into health. Yes. And I think that's kind of how I think about it. And all the things that people are listening to and hearing about, whether it's saunas or, peptides or exercise or whatever the modifications are, or NMN or whatever the molecules are, they're all affecting these fundamental systems. And I think that's the kind of the home kind of core message I want to get to today. And with that framework, I want to dive into this concept of immune aging. Is you look across all the diseases of aging, they're all related to inflammation. Brain aging is inflammation, Alzheimer's is inflammation, cancer is inflammation, obesity is inflammation, diabetes is inflammation, heart disease inflammation.
Again, we're talking about a common core.
Right. And there's a lot of ways to get to inflammation. And when you have inflammation, it affects everything else. It affects your mitochondria and your genes and your telomeres and your microbiome. It's all connected, right? So what's the cause and effect sometimes are not always clear, but the phenomena is really clear.
I can say a word about this. One thing that's remarkable about inflammation it's a normal response of your body. So, if you cut yourself, if you burn yourself, you're going to see the appearance of redness first, then there'll be a bubble, and then there's a whole repair process. And you'll see the area where it's been burned actually will stay inflamed eventually. So this is the what we call acute inflammation, which is a normal response of your body to damage. Okay, eventually that bubble is going to recede. There'll be a crust. The crust is going to fall, and soon there'll be maybe a little redness, and then eventually everything will be gone. So that's inflammation at work. Because I think inflammation is a bad name. It's something that's always bad. Inflammation is critical. This is our response to damage to fix it. The problem of aging is persistent inflammation. So
Chronic
inflammation
sterile
doesn't
inflammation.
go.
It's like chronic sterile inflammation.
Yeah, and it stays on. And what's remarkable, it becomes part of the problem. Yeah. So a body response that was there to actually heal becomes part of the chronic response. And so there's a lot of interest in trying to understand what's cause, what's effect, as you mentioned, and how do we actually suppress it and eliminate it.
I want to tell you about a supplement that I'm genuinely excited about, and maybe you've heard me talk about it before. It's been a non-negotiable in my supplement stack and something I recommend to my patients. And it's especially important for women in midlife when changes in hormones can affect energy, muscle health, and metabolism. It's a supplement called Mitopure, which supports your body's natural processes for clearing out old and damaged mitochondria, and it helps your cells create new, healthier mitochondria. Mitochondria are the tiny little energy factories inside your cells, and as we age, they naturally become less efficient. And when that happens, it can affect energy, strength of your muscles, and your overall vitality. Now, what I like about Mitopure is that it's backed by serious science. Urolithin A has been studied in multiple human clinical trials published in peer-reviewed journals. From my perspective as a functional medicine physician, it is one of the simplest ways to support mitochondrial health as you age alongside whole foods, regular movement, good sleep, and stress management. If you've been hearing me talk about Mitopure for a while, and have been meaning to try it, this is the moment. Timeline's clinically proven formula is now available at a new, lower price. Mitopure now starts at as low as $79 with the exact same science and formula. You can get an additional 20% off your first month if you order now when you go to timeline.com/Dr. Hyman. That's timeline.com/Dr. Hyman to get 20% off their new low price. If you've been listening to this podcast for a while, you've heard me talk about Seed before. Now, I've reviewed countless of probiotics over the years, and Seed continues to stand out as the microbiome company really pushing the science forward. Their DSO1 Daily Synbiotic is the #1 digestive health probiotic. It's formulated with 24 clinically studied strains designed to support gut health, healthy regularity, skin health, immune health, and gut barrier integrity, which is important. Now, what impressed me most is the level of scientific rigor behind it. In fact, that's what led me to join Seed's clinical board. They're helping set a new standard for what a synbiotic can be. So if you're looking for a simple daily habit to support your gut and whole body health, this is the place to start. Go to seed.com/Hyman and use the code 20Hyman to get 20% off your first month. That's 20% off your first month at seed.com/Hyman and use the code 20Hyman. And I think that's key. And I think, as we're younger, immune systems are very vigorous and they're very good at fighting infections and kind of preventing cancer. As we get older, it's kind of switches a little bit. Like we don't get so good at fighting cancer or preventing infections, right? And so I want to unpack that a little bit. But what I want to sort of create a little bit of a framework is a new concept that I think people are going to hear about today, which is the link and the connection between mitochondria and inflammation. They're often thought of as separate. There's like mitochondrial dysfunction is one of the hallmarks, and inflammation and inflammaging is another one, but they're not really separate. So I want to really frame that up as we're talking about this. So let's talk about this concept of how sort of cellular energy and mitochondrial function and inflammation and immune aging are connected.
Maybe I'll say a word about the hallmarks of aging first, because I think it will put everything into context.
Yeah.
So this hallmarks of aging that you mentioned, mitochondrial function, senescent cells, and all this was a way for the field to organize all of our different activities. Everybody was doing research. There was no organization.
The blind man and the elephant.
Exactly. And so people sometimes were working on something similar. They just did not call it the same. So this hallmark of aging review was published by Guido Kremer and his colleagues and organized these molecular manifestation of aging. So that's what they are. The paper was published. It created a lot of excitement because we were finally starting to think about a problem in all of its dimensions.
Yes.
Okay. And so meetings were organized on mitophagy, on senescence, and so on. What people fail to recognize is that biology is a series of incredibly intricate networks. So there's not such a, you can't put these hallmarks in neat little boxes.
That's what I was trying to say, yeah.
And so that's the reason I'm bringing this up, because when we think about, most people think about mitochondria, they think, oh, mitochondria, that's energy power for the cells. Well,
simplistic.
It's very simplistic, because the mitochondria is also an incredible sensor for what's happening in terms of inflammation. An example that I like, how does mitochondria connect to inflammation? So if your mitochondria are not functioning well, they generate what we call radical oxygen species, these
free
ROS,
radicals.
Free radicals. These free radicals are nasty. They will by themselves create inflammation.
They're oxidants, right? We take antioxidants,
they're pro-oxidants, exactly. That's where the whole theory of antioxidant came from.
That was Denham Harman way back when, yeah.
Exactly. Not recognizing that free radicals actually can also be positive.
They're cell signaling molecules.
Exactly.
So is inflammation. Everything is like a signal, right?
Exactly.
And it can be too much or too little, and that's what the balance is the key.
Totally. And so having a lot of oxidative stress is not good, and you can tamp it down. You're probably going to do yourself some good, but you can't block it all, because then you run into a whole series of other problems. So that's one way by which, if your mitochondria are not functioning well, you're going to create more oxidative stress. Another way is mitochondria.
And oxidative stress leads to inflammation.
Exactly, a direct link. Another way, which is actually fascinating, where there's so much work going on right now, is you might be aware that mitochondria have their own DNA.
Yeah.
Okay. So
from your mother.
Yeah, exactly. Mitochondria are actually descendants of a bacteria that was absorbed by our cells and formed a whole kingdom called the eukaryotes. And so we have within our cells these bacteria that have their own little genome, and they replicate, and
and they look like a bacteria.
Yeah, exactly. They look like a bacteria. Now, we have in our cells mechanisms that allow us to recognize the presence of DNA in our cytoplasm. Remember, the DNA is normally in the nucleus of the cell. The only way you can get DNA in your cytoplasm is for two reasons. Either
And so, baby, cytoplasm is like the liquid inside your cell, like the cell is like a baggie.
Exactly.
And inside the baggie is like your nucleus and the mitochondria, but there's also this squishy liquid, and that's the cytoplasm.
Yeah, okay, perfect. So sorry for getting too technical. But all of you...
I'll stop you if I got to translate.
all of your DNA is in the nucleus, and it should stay there. So if your cell gets infected by a virus, there's a system in the cytoplasm that will recognize the presence of abnormal DNA.
Viral DNA.
And it will viral DNA, and it will activate an inflammatory response. The same thing if your mitochondria get damaged, they start leaching out their DNA in the cytoplasm. That's also recognized as an inflammatory signal. So the body does not know. It says, oh, there's something wrong.
It doesn't recognize even your own mitochondria as you. It sees it as a foreign mitochondria.
Yeah. And so there's a whole system called CGAS STING. There's new inhibitors that are targeting this, that are showing amazing effects. So again, a completely new, different direction of research. What other mechanism by which I'm trying to think? I think this would be probably the two major ones.
But also inflammation and it also affects mitochondria, so it's bidirectional, right?
Yes.
If there's an inflammatory signal from your microbiome, for example, which is most people have terrible bacteria, that can affect your mitochondria.
Absolutely.
Or if there's an environmental toxin which creates an insult to the mitochondria, that can also create inflammation, because these are autogens, right?
When you age, for example, your NAD levels decrease. We've talked about this before together.
You can go back and listen to our old podcast on NAD.
Yes, NAD is critical, for example, for mitochondrial integrity and function. So as you age, these mitochondria become tired. They don't divide as well. They're not cleared as well. They don't generate as much energy. So the whole series of problems that are linked to the aging process that makes it makes your mitochondrial a really essential pivot in all of this. And the immune system is is like any other system, like a muscle system. You don't have the same strength when you are young as when you are old. The same thing. Your immune system is performing at a much lower level.
So let's kind of unpack the immune system starting there. There's two parts, really. There's the ancient, generalized, like carpet bombing immune system, which is preserved, in many, many species. It's not so smart. It's just like a kind of a firebombing a city, as opposed to our kind of smart targeted bombs.
Yeah.
And that's called the innate immune system, or the ancient immune system. And then there's the adaptive, or that's also called the cell-mediated immune system, which we learned in medical school, which is mediated by the T cells. And then there's
the B cells.
And the B cells. And then there's the adaptive immunity, or the antibody immune system, where we create specific targeted antibodies. For example, against COVID, when we check our COVID test, that's what we're checking as antibodies. Can you kind of unpack what those are, what they do, and how they change as we age?
Great question. So think about, again, two systems. Innate, first line of defense.
And I promise you, everybody, we're going to get to the news to use here. I just want to kind of lay the groundwork here.
Yeah. First line of defense is the innate immune system. Think about a country defending itself. It would be the barbed wire at the border, or maybe a series of people who are, arming the border, making sure nobody crosses. We talked about DNA in the cytoplasm. That's part of the innate immune response. So there's a whole series of receptors that allow every cell to determine whether there's a danger signal.
Yeah.
Okay. During aging, for example, we have a disruption of the gut barrier. Some of the bacteria in our intestine can leach out into the blood, and they cause inflammation. Simply that, the disruption of your gut barrier will cause inflammation because some bacterial product are leaching out across, again in the blood. All of your cells see that and they think there's an infection. And so they activate the first line of response. So that's inflammation, by the way, is that innate immune response.
The chronic sterile age-related inflammation.
Or acute as well. You have damage, you burn yourself, there's damaged tissue that's recognized by the innate immune system. It starts repairing. That part of the immune system, as we age, becomes hyper-responsive. It just sees problems where there's none. And that's a whole concept that people have called inflammaging.
That's what I was getting at when I said related to the aging.
So that's inflammaging. The second part of the immune system you mentioned is the adaptive, which is totally different. It's actually an educated system. It will learn from what it has been exposed to. So imagine you get an infection with influenza with a virus. The body will learn how to recognize it, and it will develop specific tools, T cells and B cells, that will make specific targets. That's the basis for vaccination. When you get a vaccination, you get a little dose of something. The body learns how to recognize it, and it will confer a protective response that will last sometimes a lifetime. So
like a measles vaccine, right?
Measles vaccines, or even infection that you have when you were a kid, herpes zoster. You can have chicken pox when you're a kid, and for many people, you actually have immunity for life. Although you should get your shingle
shot.
I hope we can talk about this, because this is really fascinating in terms of the implication of some of these vaccinations. And that system, the whole immune system that's adaptive, depends on, in part, from your thymus.
Okay. Thymus.
Yes.
Thymus is a gland. It's called sweetbreads. And
exactly. Some of us.
I had them the other night for dinner.
Yes.
Hoping it's going to help my immune system, but I don't think it works like that.
No. So that's exactly what it is.
Which shrinks as we get older.
It shrinks as we get older. By the time you reach 50, most of us, it's gone. Now, the problem when you do this is you're not able to generate the new cells. So you are living with the number of cells that you had at age 50. And these cells dwindle slowly over time, so that your immunity, your ability to mount a new immune response will decrease. So that vaccinations are given mostly when you're young, and as you get older, your ability to mount a vaccination response decreases.
You don't respond as well to vaccines.
You don't respond. And for example, if you get a flu shot, you're going to get actually a specific flu shot for older individuals that will try to trigger your immune system more forcefully.
Mm-hmm.
And so this failure of adaptive immunity as you age is one reason why we saw during COVID-19 the risk of death increasing so much during age as a function of aging.
Yeah.
This is why 30,000 people, I believe, still die from influenza every year. The same thing with RSV. So there is an epidemic that no one talks about, which is the fact that older individuals die from viral and pneumonia, all these infections at much higher frequency than younger ones. So there's a lot of interest in the aging field to try to say, how can we mitigate this? Can we restore the thymus? Can we understand what makes the thymus go away? And so on.
So it's almost like the worst of two worlds. On one hand, the innate immune system starts to be overactive and more indiscriminate, and creates this low-grade chronic sterile inflammation that we call inflammaging. And at the same time, our antibody levels are less able to mount a response. Their cells that do antibodies are less able to mount a response to invaders. And so we can't fight cancer, we can't fight infections as well. And so we get all these different problems.
That's a great point. You can respond to a vaccine in the same way. As you mentioned, the immune system, the adaptive immune system, plays an important role for what we call a tumor surveillance. So it goes around the tissues and it tries to determine, is a cell acting funny? Is it senescent? Is it a zombie cells? If it's a zombie cells, we'll try to eliminate it. So there are many mechanisms by which the immune system participate in our health. One last point is the fact that these two immune systems do not function independently from one another.
Right.
System is really smart. So the innate immune system, when it's activated, actually provides the help to educate the adaptive immune system. And so if you have a chronically active innate immune system, that doesn't jive well with the adaptive. So the whole system degrades as we age.
And so as people are listening, they're, well, this isn't good news, right? The immune system ages. You can't mount responses to infections or fight cancer. You get this chronic inflammation that creates a downstream cascade that leads to all these chronic age-related diseases. What do we do about it? How do we manage that? Is there a way to kind of reduce inflammation or to stop the inflammation or to improve immune response? How do we do that, given what we know in longevity now? Because immune aging is what we're talking about.
Yes, it's very hard to sort of, first thing I should say also, why immune aging is so important. There's evidence that if you induce aging only in the immune system, and we can do this in mice, okay? So you can make a lesion only in the immune system, that will induce organismal aging. So it will not just induce aging of the immune system, it will induce secondary aging in the other organs. And so that's been shown in 2 different studies. So it's real data in mice. Creating these artificial tools that we have, we can make only a lesion in the immune systems, which means the immune system has a dominant role in our aging. That has been proven in another way. You might have heard about the new clocks that Tony Whisker has generated, these organ-specific proteomics clock. Okay, so you can
Is that Generation Labs? Is that
it's a Vero.
Vero Labs,
Exactly.
I know, that's right.
So what this company and Tony's work have shown is that they now can draw from a blood jar, they can measure a series of proteins that are circulating that are reflective of the activity and the health of all organs. So they can determine
like an organ clock, how old your brain is, how old your heart is, your kidneys. Right.
Because obviously, you can be in incredible health in your whole organism. If your brain health is 20 years ahead, you're going to be not doing so well. So there's always that sort of rate limiting organ that could be causing all of the problems. So we want not to age at an accelerated rate in any organs. But what his data, they've gone back and analyzed 50,000 people from UK Biobank, huge data set from England, and they found that there are 2 organs that are predictive of your demise in terms of your lifespan. It's the immune system and it's the brain. And it's not that surprising because they are the 2 organs that are distributed.
They're the sensory organs.
Yeah, and your brain, your brain has ramification in the whole organism. Your nerves, your brain does not just sit in the cranium. It sends, nerves to the whole body for muscle, but also to your organs and so on. So same for the immune system. It's not only sitting in your lymph nodes, it's in your skin, it's in your liver, it's in your gut. It's absolutely, half of your immune system is actually in your gut. Yeah. So that means that all of this data in aggregates mean that maintaining immune health is really critical. And it's going to be one of these, we used to think as physicians that the critical organ for survival was your heart because half of the population was dying of heart attack. And we still have that problem. But beyond this, let's say we can cure heart attacks, as I think we will in the near future.
But also that's related to inflammation.
Yes, but that's also, so maintaining immune health is going to be really critical.
I know you've heard me talk about the importance of getting enough protein to maintain muscle as we age, but sometimes even when you eat well, meals can leave you feeling heavy, bloated, or sluggish. Now, in some cases, it's not protein. It's your digestion. And our bodies rely on enzymes to break down protein and fats and carbohydrates so we can actually use the nutrients we eat. Now, with stress, with age, or busy lifestyles, enzyme production can fall short. And that's why I recommend Masszymes from Bioptimizers. It contains 18 different digestive enzymes, including 4 times more protease than many other formulas, to support the breakdown of protein, fat, and carbs. Supporting digestion can help turn meals into clean fuel, so you feel lighter, more energized, and more comfortable after eating without changing your diet. If your goals this year include eating well and feeling better after meals, well, Masszymes is a simple way to support healthy digestion. For an exclusive offer, visit bioptimizers.com/Hyman and use the code Hyman to get 15% off. Subscribe and you'll get extra discounts, free gifts, and guaranteed monthly supply. That's bioptimizers.com/Hyman and use the code Hyman today. One of the most fascinating areas of research in functional medicine right now is red light therapy. Now, specific wavelengths of red light have been shown to support mitochondrial function, essentially helping your cells produce more energy. And when your cells have more energy, your body is better able to support natural recovery processes. And that's why I've been using products from Bone Charge. They're a wellness brand focused on science-backed tools that help counter the stressors of modern living. Everything from blue light blocking glasses to circadian lighting and red light therapy. One product I really like is their red light cap. It uses 650 nanometer red light to deliver targeted light energy directly to the scalp, encouraging natural hair follicle activity to promote hair growth in both men and women. It's incredibly easy to use. Just wear the cap for about 10 minutes while reading, cleaning, or answering emails. The high radiance LEDs deliver targeted red light therapy in a comfortable, lightweight design you can use right at home. Bone Charge ships worldwide, offers free shipping on the red light cap, a 12-month warranty, and it's even HSA and FSA eligible. So head to bonecharge.com/Hyman and use the code Hyman for 15% off today. That's BONCHARGE.com/Hyman and use the code Hyman. Well, you make an interesting point because the way I think about the brain and the immune system is the brain is the sensory organ for macroscopic things. The immune system is the sensory organ for microscopic things. Yep. So they're kind of mirrors.
They're very, very important in maintaining tissue integrity and so on.
So what do you do for helping your immune system age well? Dr. Verdin.
That's a tough one. So I think...
or at least better phrase, what do you think the science best says we should do?
Yes. First, we have to mitigate inflammation, okay? Because I think, as we've talked about, inflammation is not only a response, it becomes a driver.
Yeah.
And there are lots of sort of self-amplifying loops that happen there. If your immune system becomes activated, it can actually induce that. It can try to repair, but eventually it can actually cause damage.
The solution becomes the problem.
The solution becomes the problem. And so mitigating this inflammation is key. And one area, for example, that I think there are multiple areas that we can talk about. Gut health, I think, is critical in this respect for me. And I tell people this is something that not enough people are talking about in the longevity field. And actually the people who are talking about it, I think, focus on a lot of the wrong things. A lot of focus on probiotics. And I think we should be focusing on prebiotics and postbiotics.
Yeah.
And I'm happy to...
I want to get into that. That's a topic we're going to get to.
It's a great one for me, and one that I think we're not talking about enough.
And if you ask most doctors, how do you create a healthy gut? They have no idea.
Yes.
And there's a way to do it. I mean, that's what functional medicine, the joke about me where at my old job at Canyon Ranch was I was Dr. See every poop because I wanted to look at every stool test, look at every microbiome, see what's going on, reset the gut as a way of treating all these kinds of diseases.
Agree. Totally agree. And I think for most people, like, totally unaware. And, the only thing they think about this is when you walk into a Whole Food, there's a fridge full of probiotics that I said, I wouldn't go near those if I were you, because we except maybe for Akkermansia, most of those, we don't know how to use them, or maybe lactobacillus.
And your diet is what creates your microbiome for
exactly.
For the main reason. And you're focusing on prebiotics. These are foods, whether it's asparagus or just some artichokes or plantains. Or these are things we can eat that actually feed the good bugs.
Agree. Or if you're not able, and actually the evidence points to the fact that so prebiotics would be all fiber. And most of us actually have an inadequate intake in our modern way of eating of fiber.
Yeah.
And so I tell people, if you have to supplement, but there are a growing number of good supplements that you can take.
I mean, it's staggering when you look at the historical fiber intake of hunter-gatherers. It was like estimated to be 150 grams of fiber a day. We 8 to 15. And the average American we should be trying to get to 35, 40, 50 at least,
My wife is from Germany, and I suspect you've traveled there when you eat a slice of bread from Germany.
Yeah, you need a meat slicer. I visited a friend of mine in Germany when I was like 20 something, and she had one of those like deli meat slicers in her kitchen. I'm like, what is this for? She's like, for cutting the bread because a knife doesn't work.
Yes,
it's dense.
And that bread is, but the other way is this bread also will force you to chew and will get you a large jaw, which will stop sleep apnea. Right. So there's a lot of interesting things in terms of the fact that our diet has become almost like semi-liquid, creates all of these problems in terms of facial features and so on. So
that was the work of that dentist who went around. I forget his name right now. The guy who went around to all the indigenous cultures and looked at all the teeth and the jaws. Yes. I mean, I was in Africa and I saw the gorillas, and I got to go to the museum and I got to see all the gorilla skulls. Perfect teeth. Like they have perfect teeth. They don't need dentures. They don't need, they don't need braces. I mean, it was amazing to see. And I was like, wait, that their diet is what's driving their dentition, and their dentition is driving their health.
Absolutely. I'm reading James Nestor's book, Breathe.
Yeah.
Or Breath. I don't know. And that there's a whole chapter on this. There's this sort of adventurer who was one of the first one to actually visit American Native Indians.
Yeah.
And what was one of the things that struck him the most is how the teeth of all of these Native Indians were absolutely perfect, no crooked. They didn't have to remove wisdom teeth. They didn't have to do anything. Right. So that's a fascinating aspect of it. But I think the two are linked. So this idea that we're eating a semi-liquid diet, soft bread, soft everything versus chewing hard has implication not only in terms of our microbiome, but also our tooth structure, our ability to breathe through our nose and so on.
So whole foods, fiber
is the root of everything.
Yeah, so phytochemicals, fiber, whole foods, getting rid of processed food, sugar, all that's going to be the biggest lever for inflammation, stress, sleep, removing toxins. These are the things that I think about. Do you think about those? Is there anything else?
This is the foundation. And I think,
sleep, stress, exercise, food, toxins, and microbiome.
Human connection.
Human connection,
All of those is, for me, the foundation of longevity medicine. Yeah. And, it's people have argued, well, this is not sexy. This is not what people want. They want supplements. They want drugs. They want a shortcut. And I'm all for shortcuts, but I believe it just doesn't work.
Yeah.
And also plus none of these shortcuts have been proven. The rest of everything else has been proven, the effect of physical activity and so on. So the stance that I've taken lately, sort of social media and talking, is one that is a bit contrarian to what some of my colleagues are advancing in the longevity field. I'm as excited as anybody by what we're going to be doing 20 years from now. But let's not forget where the foundation is. And we can create so many problems that are so easily solvable as a society. Not everything needs a pill.
Yeah, one of the most interesting studies I ever saw was a whole field of sociogenomics, which I kind of came up with on the term myself because I kind of saw Paul Farmer's work in Haiti and how he helped people and using community health workers to help. And I just came up with this concept, and then I started researching it, and I was like, wait, there's a whole literature on how our social connections affect our immune system, and that if you're in a loving, connected relationship or in an interaction, it's going to reduce inflammation. But if you're in a conflictual, literally inflamed relationship, it's going to create inflammation. Which
I love that whole aspect.
Yeah, it's really interesting.
And it's
more cuddle puddles.
Yes. Incredibly frustrating for me that we know from the happiness studies, for example, that the biggest factor determining your longevity is your social connections.
Yeah.
The number of loving relationships you have, your sense of purpose. The problem is that these are also the hardest one to study, especially in animal models. I can't go ask a mouse what its sense of purpose is, living in a little plastic box and eating the same food that looks totally disgusting. Right. So there is we've been talking actually at the back about creating a center for the psychobiology of aging, which would really try to, because at the end, everything is driven by molecular mechanism. I mean, we are biochemical feature.
Could you reproduce like a whole natural mouse environment?
Yes.
Like
People
dirt.
are doing this.
Yeah,
Kind
so
of
I suppose
interesting.
like a cage. Like
they're creating these really, and we study longevity, by the way, in these mice that live like these prisoners. I mean, they're alone in their cage. There's no distraction. There's nothing to do. The food is there all the time. It doesn't taste good. Imagine, I mean, the mice, I'm sure, have the same needs that we do in terms of having a diversified environment and so on. So there's a whole group of people thinking that we should create these, and maybe the drugs that we find that work in mice would be a lot more relevant to what we have to do in humans.
Amazing. All right, this is so good. So I think we kind of got a good dive on the immune system. Let's kind of switch over to mitochondria and help us understand how mitochondria and cellular energy are so central to aging. Because to me, they're kind of like the final common pathway that goes wrong, and inflammation is causing them to malfunction. And how do we understand how that's occurring and why and what we can do about it?
Yes. So where do we start?
Let's start with like why are mitochondria and cellular energy so important to aging?
The big reason that everyone knows is most people agree on is the energy requirement. So everything that we do is dependent on energy. When people think about moving your arms, thinking, everything that we do is depending on generating energy. Typically, we get that energy from our food. Okay, so we're able to extract energy from the food. The place where that energy conversion happens is in the mitochondria. Okay, most of our energy generation happens in the mitochondria. We also know that as we age, so all of these activities, thinking, moving, are the two major ones. But there's a whole other aspect of energy that most people do not appreciate, is that repair. So we are constantly subjected to toxic insults.
Yeah.
Okay? We talked about free radicals that really induce damage in our proteins, damage in our DNA, damage into our membranes. All of these lesions, these damage, have to be repaired.
Yeah.
So we have in our cells little monitoring mechanism that constantly look at everything to make sure everything is fixed. As soon as sensors, as soon as something is seen to be damaged, a whole crew is sent to repair it and fix it. For example, I'll give you an example of DNA damage. Your DNA is the code that encodes every one of our cells. It stands to reason that if you're making a damage and you're creating a mutation, you have the potential to change the code. And essentially, so if you allow this to happen all the time, eventually the whole system is going to go awry. So there are human mutants who are people who carry a mutation from their parents where they are not able to repair DNA damage. They typically live until 20.
The progeria patients?
Yeah, some of these progerias. So there's a whole series of syndromes, xenoderma pigmentosum, ataxia telangiectasia, a whole series of these DNA damage repair, all really tough disease to live with many of them with very shortened lifespan. So that highlights how important all of these repair pathways. We also have systems to repair unfolded proteins. Remember, proteins is a string of amino acids. It has to be folded in an extremely precise manner to function. If it becomes a little unfolded, all of a sudden, it's creating problems.
And that's one of the hallmarks of aging is protein damage.
Yes, proteostasis, the idea of maintaining all of your protein in good shape. Again, there's a whole series of enzymes that we call chaperones that are sent. If something is unfolded, they're sent. But all of this refolding takes energy. And so our body always makes this calculus, okay, what do I repair? What do I not repair? And so we try to repair as much as we can, but there's an energy cost to this. Okay, so you also have to move, so the difficulty for a living organism is how much energy do I allocate to repairing everything perfectly, or what can I live with and still move, still hunt, still procreate, still. So this antagonism between repair and reproduction is really at the root of aging. And so as we age, the mechanism of production of this energy starts become limiting. We mentioned these bacteria these mitochondria become old.
But there's a way to repair them and renew them, right?
That's the key. So there's actually a special repair system just to get rid of old mitochondria that are damaged. It's called mitophagy.
Yeah, it's like autophagy, but
Yes.
it's for your mitochondria. Autophagy
Exactly.
is where you kind of eat yourself and clean yourself
Totally.
up.
And autophagy is activated when you're resting and actually allows you at night to actually repair a lot of the damage. And what's amazing about autophagy is that it's a self-eating mechanism that specifically targets what's been damaged.
Right.
So imagine you're not eating, so you still need energy.
Yeah.
And that energy now has to come from the inside. Your system has a mechanism that goes to clean up the attic first.
Right.
It doesn't destroy the kitchen.
Right.
It goes into the attic and says, okay, what's all the garbage here that I can still, resell and make a profit without actually touching the kitchen. So, and mitophagy is an arm of this that selectively targets defective mitochondria because they are so central. But like everything during aging, so what is aging? The progressive accumulation of damage. So even though we have all of these repair mechanisms, we don't repair perfectly.
Yeah.
We've repaired pretty good. During our 20s, the rate of repair is such that if we were to continue repairing at the same rate, we would live to 1,000 years old. Yeah. So during our 20s, we're actually doing incredibly well. The problem is, as a little damage accumulates over time, eventually some of the damage might actually target the repair mechanism. And we know aging is not a linear process. It accelerates. Yeah. The older you get, the faster your aging process. Yeah. And so the whole idea of reactivating mitophagy, because eventually as you get old, mitophagy becomes limiting as well. It doesn't function as well. So
cleanup system.
Your
garbage men get
exactly,
old.
Exactly.
That's right.
Exactly.
When I think about this, it's such an important kind of framework to think about the sort of energy of the cell, because it really runs everything.
Yes.
And we kind of do know that everything that impacts aging also impacts the mitochondria and vice versa. And there are levers though to really take care of your mitochondria. Yes. We talked about NAD on our last podcast, but there's other compounds that induce mitophagy and that are, when we mentioned postbiotics earlier, which are essentially compounds that you eat from food that get metabolized by your bacteria, and they produce downstream molecules that have function in the body, which I think is a miracle. Just when you think conceptually about it, that you eat stuff and then it creates like literally a medicine that turns on different signaling systems in your body to help you repair, renew. And I think from my perspective, and it sounds like you think the same way, when I think about aging, I think, the body has these innate systems of repair, renewal, regeneration. We just burden them. And we don't take care of them.
Yes.
And that's why we age faster. And instead of focusing on treating disease, if we focus more on our regenerative, renewal, and repair systems, we do a lot better. And so the way in is through some of these food molecules. And I have this joke, I call it a symbiotic phytoadaptation. We symbiotically evolved with plants and use their compounds to regulate our biology, and because we're lazy. Like we don't make vitamin C, so we get vitamin C from food. We don't make, for example, one of these postbiotics called Urolithin A, so we make it from pomegranate or other ellagitannins that are in, walnuts or berries or whatever. So kind of help us understand how, for example, this molecule Urolithin A, which you published on, and we'll link to the papers in the show notes, and which I, by the way, take every day because the literature is impressive on it. What does it do, and why is it getting so much attention now? And we kind of learned about it more in the context of exercise, improving, exercise capacity, VO2 max, and fitness, and muscle health, and mitochondrial health. But it does have a link to immune system. So what is it, and how is it linked to these things that we just talked about? So I'm wrapping back up with immune function, the gut, and mitochondria, because it's like one thing.
It's a really cool story because it's one really, I would call it a sort of a human ingenuity. And so in some way, we've known for a long time that pomegranate juice is actually healthy for people.
Yeah.
And there's a whole, there have been studies showing that consumption of pomegranate juice is actually confers some health benefits. What was not clear is what the mechanism. So some scientists, a good friend of mine, Johan Aurix, who works in Lausanne, actually went and looked for what is in pomegranate juice. And they found these ellagitannins, these compounds. What they also realized is that these compounds are not acting by themselves. They are actually metabolized by your microbiome. And that's really, and the product that is made by your microbiome is called urolithin A. Okay, now what's the catch is only about 35 to 40% of people's microbiome, because remember, all of our microbiomes are different. And some 60% of people's microbiome is not able to make that conversion.
So we trash them because of our diet, because of antibiotics, because of toxins, all this stuff.
Yeah,
so we kind of
having a rich, most of us have more than 1,000 different species of bacteria in our guts. And the problem, the complicating factor is most of us have different species. So you cannot compare your microbiome and mine, even though we might both be very healthy.
But they can change. Like I've seen the site where you have people on a vegan diet or a meat paleo diet, and their microbiomes literally in the same person will change.
Yeah. Right. We don't know how to read it well, but we know certainly what upstream factors can actually yield a really complex and rich microbiome. Yeah, so this is a clear example of where sort of human ingenuity has been able to identify a single molecule, urolithin A, that is the result of a input from a food product, from a plant, pomegranate juice. It gets transformed by a fraction of us into a product that has immense benefit. So company was founded based on this. I'm a scientist that actually sells this product and we've been working with them. Full disclosure, I sit on the board of that company as a scientific advisor, but I always tell people I don't sit on the board of supplement company if I don't believe in the science and if they're not willing to actually conduct clinical trials. And it's one thing I think is commendable for Amazantis. They've been going through clinical trials one at a time to actually document and prove the efficacy of what.
I agree. And they're a sponsor of the podcast. And that's why also I don't let everybody sponsor my podcast. You imagine all of you will ask me, because I think I want stuff that I know has legitimate science behind it. And this is published in major journals like New England Journal or JAMA or others sell. Yeah. So I think this is important.
So to me, I'm not opposed to supplements, but we have to apply to them the same kind of standards that we've applied to generating all of the drugs that we have, and that's how medicine has moved forward. So that being said, we've worked with them on a couple of studies. We still have another study going on with them. So urolithin A has this remarkable ability to activate mitophagy. And mitophagy is not sort of the, as the term implies, it's eating mitochondria, but it doesn't eat them discriminately. It eats the old defective mitochondria, which is absolutely remarkable. So when you do this, actually, one of the studies that we've done was looking at the human immune system of all the people on urolithin A. And what we found is really actually significant effect, even within 1 month of administration of urolithin A. We saw some, I would say, what anybody would call a rejuvenation of the immune system.
Yeah. I mean, I think, early on when I looked at the data, this is years ago, I got excited about it. I saw like a reduction in CRP, which is a very crude marker of inflammation, and we measure with functional health, but there's even better markers. But what are the things that you looked at that indicated that it helped to reduce the inflammation process?
Yeah, actually, in our case, some cytokines. We measured the presence of different cytokines: TNF alpha, IL-6, IL-1, and I don't remember exactly which ones were changed, but some of them were.
And cytokines are the messenger molecules of the immune system.
Exactly, and they IL-1, IL-6, TNF alpha are pro-inflammatory molecules. So the higher the level, the higher the inflammation. What we focused on in my lab and with our core at the back was on looking at the adaptive immune system. And what we saw was actually quite interesting. We saw an increase in naive T cells. So these are the precursors that are really critical at generating an adaptive immune response. We saw a whole series of other changes.
And just in English, naive T cells are kind of cells that haven't made the antibodies yet. They haven't kind of
They haven't been activated to
develop antibodies.
The T cells, and the B cells would be making the antibodies. So these are the T cells
that cause the B cells to make the antibody.
They help, but they also by themselves can generate what we call cytotoxic T cells, CD8 T cells, which are the other. So the innate immune system, the adaptive immune system has two arms: T cells and B cells.
Yeah.
The T cells are they can kill bad cells. The B cells can actually secrete the antibodies, which help in the immune response.
And so the urolithin A works on the T cells.
It worked on the T cells and actually increased the ability of these T cells to recognize their targets. Now, this has implication not only for the person who's taking this, but think about, you might have heard about the CAR T cells that are used now for cancer cells, where we can extract T cells from a patient and educate them to selectively kill tumor cells. And the problem is that as you get older, your ability to re-educate these T cells goes down. And so this would have even implication for cancer. Because they did it in vitro and showed that these CAR T cells were actually more effective.
So it makes immunotherapy work better.
Exactly.
If you improve and rejuvenate your T cells.
Totally.
Before you start to sort of target them for cancer. That's amazing. So how does Urolithin A affect like the whole process of longevity, the muscle, the inflammation? Like, what do we know about it?
Mitochondria are not just present in the immune system; they're present in every cell. And so, think about the concept.
Except for red cells.
Except for red cells, exactly. They don't have a nucleus. They don't have mitochondria. I think they have mitochondria.
Oh, they do? As you know, I talk a lot about protein, especially as we age, but not all proteins are the same. Collagen is actually the most abundant protein in your body. It's the glue that holds you together. Your skin, your joints, your bones, your connective tissues. And after the age of 20, our bodies start producing less collagen, which contributes to the changes we notice in skin, in joints, and in bones over time. Traditionally, we got collagen from nose to tail foods, think slow-cooked stews, bone broths, and connective tissue. But most modern diets don't include those foods, which is why supplementing with high-quality collagen source can be really helpful. And that's why I like Paleo Valley's 100% grass-fed bone broth protein. It's made from bones of grass-fed and finished cattle raised on American regenerative farms. And it's made simply with water and bones. No harsh chemicals, no fillers, and it's rich in collagen and glycine, which is an amino acid we often don't get enough of. Now, collagen supplementation has been shown to support skin health and joint comfort, and glycine may have a role in overall health as well. I'll often add it to my tea or a smoothie, and the chocolate flavor even makes a delicious hot cocoa. It's an easy, ancestral-inspired way to support your body with collagen every single day. So head to paleovalley.com/Hyman for 15% off or use the code Hyman at checkout. That's Paleo Valley, PALEO Valley.com/Hyman for 15% off and use the code Hyman. As we head into the busiest stretch of the year, longer days, travel, more on your plate, your immune system is working overtime. And that's why now is the time to make sure you're giving it the support it needs. I rely on HTB Immune Energy Chews from Big Bold Health. Each serving delivers 1,000 milligrams of sprouted Himalayan tartary buckwheat, a powerful seed packed with over 100 immune-active polyphenols like quercetin and rutin. Now, these compounds are studied for supporting healthy immune balance and longevity, but it doesn't stop there. Each chew also includes vitamin C, vitamin D, magnesium, and zinc, all nutrients your immune system depends on, especially when you're pushing hard. And because they're chews, not pills, they're convenient and delicious. Perfect for your bag, your desk, or wherever the day takes you. If you want a simple way to support resilience, energy, and focus this summer, try HTB Immune Energy Chews. Go to bigboldhealth.com/Dr. Hyman, that's DRHYMAN, and use the code Hyman15 to save 15% off your first order.
When we think about mitochondrial function, it's not restricted to the immune system. It's pretty much every cell that has to balance repair and dividing and moving forward. So when we think about urolithin's effect, they're going to be pretty much across the whole organism. And we focused so far on the muscle, where we could see increased endurance in people, actually on humans on Urolithin A. We've seen increased immune responsiveness. My prediction is that when we start looking in the brain, we might see increased performance, increased memory, and so on. Not been proven yet, but this is a molecule that's not just targeting the immune system or an organ.
You call it pleiotropic.
It's pleiotropic, and I think my prediction, I don't think this has been shown yet, but you can imagine that it would have real anti-aging effect.
Yeah, I think this is interesting because we often looking like drugs affect a single target. They're a single molecule, a single receptor, a single target. When you look at these longevity interventions, they have diverse effects across all these different systems. So a compound like Urolithin A has many different effects across the system.
That's an important point, and it goes back to this whole idea of what we talked about, geroscience. What does geroscience really mean when we talk about aging being at the root of everything?
Like geriatrics, like gerontology. That's
the
root of it. Yeah. But it's the root of it. That's what that means.
There's another example, because these, the way we practice medicine is based on a model that dates back to the 17th century when we discovered organs. You go see a heart doctor, you go see a neurologist. There's a National Institute of Health, which has a National Heart, Blood, and Lung Institute.
It's a National Institute of Organs.
Exactly. So first, it's a National Institute. It's not a National Institute of Health, a National Institute of Disease. And second, it's based on a 17th century model. Now, when we talk about Urolithin A, it's not that it's going to help your immune system. It's going to help everything. Same thing, think about rapamycin, which is another darling from the longevity field. Its target, called TOR, target of rapamycin, is not only in the immune system. It's in your brain, it's in your muscle. So when you give rapamycin to someone, you're not affecting just the immune system, you're affecting pretty much the whole organism. And that's the shift that longevity medicine is doing, from sort of organ-based reactive model to a sort of system-based proactive.
Yeah, you treat the system, not the symptoms or the diseases. That's essentially what functional medicine is. It's what I've been doing for 30 years. And it actually works really amazingly well. You really get to the root cause, like you were talking about the root, not the branches and the leaves. And that's even the paradigm we use to describe what functional medicine is. We treat the root and the trunk, not the leaves and the branches.
And as a physician, I've been a fan of this approach of medicine. I think what longevity has done is to add a little bit of a more exciting aspect, frankly. And I think my hope is that this is a reintroduction of many of the concepts of functional medicine through the eye of longevity. And for some reason, it's resonating more with people. It's become kind of, longevity has become sort of a buzzword, which scares me also to some degree. But I think it's a wave that we should ride, because it will, in the end, change the care for patients and make it much better.
I agree. And I think, the way I think about functional medicine is a heuristic. It's just a tool that we use to think about things. It's not the thing itself, because trying to describe the human body is infinitely complex, but we're trying to organize it just like we organize the hallmarks of aging. But when you look at the functional systems that we describe in functional medicine, they almost map perfectly across the hallmarks of aging. Mitochondria, immune, microbiome, nutrient sensing, all these things are all part of this. And so we may improve that model and become smarter and smarter, especially as we start to dive into the complex biology that we barely have scratched the surface of, with proteomics and transcriptomics and metabolomics and the microbiomics and that's like, at Function Health, we do like 160 biomarkers at first flush, and there's more you can add on, but there's literally thousands and tens of thousands of genes and, millions of variations in your genetics. And there's tens of thousands of proteins, and there's, thousands of metabolites. And it's almost like incomprehensible. But now with big data science and with AI, we can start to make sense of this.
I could not agree more. And I think this is...
Because no matter how smart you and I are, we're never going to understand it all.
No, and we generating data right now in patients at a rate that is beyond anybody's comprehension. And I'm always comparing, the state of medicine today. And I'm a physician, so this is not a condemnation of medicine. This is just recognizing what it's doing. You go see your doctor and you have maybe 20 measurements, or your typical annual visit, 20 or 30 measurements. And that's what most people will rely on: their hemoglobin A1C, their LDL, not even ApoB, their fasting blood sugar, maybe their A1C, and so on.
You're lucky if you get an A1C. You're not diabetic.
Yes, and so. And a stethoscope, and a little bit sort of something that we used
17th century medicine.
Something that we used to do, 50 years ago when we were being trained.
Yeah.
Today, we can generate out of a single blood draw hundreds of thousands of different data points. And I think a lot of the work that we're doing at the Buck right now is trying to integrate all of this data, because we're generating it with crazy. AI and really
making sense of it.
Yeah, making sense of it. So these are early days, but I cannot help to be incredibly optimistic of the fact that in 10 to 20 years, we're starting with function health, others in different ways, really to generate a lot more data about patients.
We've got like 80 million biomarkers we've tested in the first few years, and we're just getting started.
Yeah.
And I remember sitting on a panel at Cleveland Clinic with Stan Hazen, who's a cardiologist who studied the microbiome and its effect on heart disease. And I said, Stan, how many of the metabolites in your blood do you think come from the microbiome? And he's like, I think probably a third, which blew my mind. I don't know if it's true or not, but when you think about that, it's like our microbiome, like you said earlier, is a completely neglected area of medicine. Gastroenterologists don't even pay attention to it.
No. Well, I'll tell you another piece of data which I keep reminding myself of is half of your immune system. So your immune system is distributed across the whole body, but half of it is in the intestinal
patches. Yeah. Why? Because it's where you're interfacing with the outside world. You're basically
with the bacteria.
You're one cell away from a sewer. So on the other side of your intestinal lining, which is one cell thick, is on the inside is like a sewer, and on the other side is your bloodstream and your immune system to kind of help take care of you. So
imagine now what you put in terms of fibers, in terms of your food, all of this has a direct impact not only on the bacteria, your microbiome. I think about the microbiome as an organ, frankly. This is an organ, an additional organ in terms of weight. It's pounds.
That's 3 to 5 pounds.
People don't realize these are pounds. This is a big...
Pounds of poop.
Pounds of poop. And all of these bacteria are digesting your food. Many cases, they pre-digest what you've eaten.
Yeah.
They're generating all of these secondary products. All of these products go into the wall of the intestine, and they educate your immune system. So this interface there is really, I would say, one of the still big black box of what...
It's interesting. And in functional medicine, we've been testing organic acids for years. And part of the things that show up in your urine are metabolites of things that are happening in your gut. So we can tell if there's yeast overgrowth, if there's bad bacteria, if there's things that are going on. It's quite interesting. And we treat people based on that. And it's pretty cool stuff.
Yes.
I mean, Eric, this is such a great conversation. I actually want to talk to you more. I'm not going to do a 3-hour podcast with you this time. We're going to break it up. I want to talk about some of your new research going forward. I think we're going to maybe do another podcast on this because it's a whole topic in of itself, which is how do we measure biological age? And I'm just going to set the stage, and I want people to come back and listen to the next podcast. But we are trying to figure out, when we say we, the scientific community is trying to figure out, is there a metric we can use to look at interventions to see if it's working? Like if you say, oh, this molecule or this exercise or this thing, if we do it, will you reverse your biological age? And there's a lot of clocks out there. A lot of people are doing this. We use one at Function, which is based on Morgan Levine's sort of calculation of biological age. And it's, it's an approximation. And I say, if you do the same clock over and over, you're going to get the same kind of variation, but they all widely differ. One clock you were 29, one you're 68, 9, like same thing I've seen. And I'm like, man, I don't like the one that says I'm 70. I like the one that says I'm 39, but you've kind of done some more research on this. I'm just going to set the stage of looking at the clock that has to do with your naive T cells.
Yeah.
And this seems to be more of a stable clock that you can kind of track. It doesn't vary so much. So we're going to come back and do a podcast on that. Okay. I'm super excited about it. We're going to put a link to the show notes.
We're going to do a full show on clocks.
I think I want to do
one
a full show on
area
clocks.
that I think is really, if I can say one more thing about these clocks, why is that important? As we move from this reactive to proactive medicine, the way most people live their life is they have their lifestyle. Their spouse or their children might tell them, let's try to do this and exercise more. Everybody's living their life flying, what I call flying blind.
Mm-hmm.
You have your doctor's visit annually. You might get a few samples, but eventually, you get into your 50s, your 60s. If you're lucky, and you've done the right thing, you're going to go right through. If not, you get a heart attack.
Yeah.
And so the question that this whole new reinvention of medicine, functional medicine, longevity medicine is really occupying itself is this, can we accompany you starting at age 20, 25, measure you maybe every day, using wearables,
Yeah.
using blood sampling. The technology is going so quickly. I don't know how we're going to be doing this. The idea for me is really this constant monitoring.
Yeah.
Nobody would fly a plane blind today.
Right.
We have incredible, but we fly our
episodic medicine just doesn't make sense.
We fly our health blind.
Yeah.
And we go to the doctor, we're nervous, our blood pressure is too high. We go home, maybe it's too low. So this whole idea of everyday measurement, hopefully in a way that's totally invisible to you, is the future. And so these clocks represent sort of the integration of many of these variables that are going to tell you you're flying not completely blind. It looks at age 30 that you're on your way to getting a heart attack at age. And we can do this now. 15 years in advance, we can identify the first signature of disease and then correct. So we don't hit the mountain with our plane. We actually correct and we go a little higher, we go a little to the left or to the right. That's really the way medicine is going to change. And I think the clock for me at this point are an incredibly promising direction.
Yeah, it's true. And I think what you're saying is right. I mean, episodic care, waiting until you have something doesn't make any sense. And I think that's really our mission at Function Health, is to actually help people to create a longitudinal data set with continuous measurements or more frequent measurements, continuous through wearables, for example, whether it's a ring or a watch or something, or a band, or even continuous glucose monitors. And there's going to be more monitoring like that. Plus regular blood testing and scanning allows you to create a comprehensive picture and actually detect signals early, these early warning signs decades before you ever see a problem. And I think that's what's exciting to me for every aspect of aging and every chronic disease. And we're getting there, whether it's cancer, heart disease, Alzheimer's, diabetes, we can see it coming a mile away. And that's what I get excited about.
Yeah, same for me.
So thanks so much, Eric. Thanks for doing your work, and great to see you again, and we'll have you back soon.
Likewise.
Okay.
Thank you.
If you loved that last video, you're going to love the next one. Check it out here.